Hello, hello. So for this problem, we want to find the area of a region, the volume of a region, and then the volume of some unknown solid, where this region is the the base. So the first thing that I think we should do is get a picture of the region that we're looking at. We are able to use a calculator for this, so if you want to use a calculator to draw a sketch of it, that's fine. But I know that the square root of x looks like this. I know that the line y is equal to x over 3, well, that's a line that goes to the origin and has a slope of 1/3. So this is y is equal to x over 3, and this was y is equal to the square root of x. So that's the region that we're looking at. If we want to find the area of this region, then we're going to need to know our limits of integration. Our limits of integration we can find by looking at the x values of the intersection points. We can use our calculator to find them, but these functions aren't too bad because, well, 9 divided by 3 is 3, and the square root of 9 is 3. So this x value of the intersection point is 9, and then 0. And just as a point of reference, this is the point 9, 3. Okay, so the area of this region is going to be the definite integral, put that in black, the definite integral from 0 to 3 of my upper function minus the lower function. And the upper function in this interval is that red one, or the square root of x, minus my lower function, which is x over 3. And we're taking this with respect to x. We're able to use a calculator, so we don't even have to do out the definite integral by hand. We could use our calculator and get 4.5. So this was A. For B, we're going to have to find the volume of this solid rotated about the vertical line x is equal to -1. So if this is an x value of -1, so here's my line of revolution, and let's think about where these points are going to go. So if I looked at this point 0, 0, and I were to reflect it over the line, knowing that I'm going to create a solid of revolution, it would be here. And this 9 would go, I don't know, somewhere over here. So those are where those 2 points would go. My line, my this, and then we're creating this solid. So I've got so it's just the region on the outside. So we kind of get like this, like open, like a kind of like a cone that you would use for like soccer or lacrosse, but it's got like a butterfly inside. So we need to find our outer radius and our inner radius. The volume is going to be the definite integral. I'll give myself a little bit more space. The volume is going to be the definite integral from some endpoint to some endpoint, and then it will be pi. We need to find these, and then outer squared minus inner squared. However, when we revolve something around a vertical line, we need to take the antiderivative with respect to y. So I need to take my two functions. Y is equal to the square root of x, and y is equal to x over 3. And I want to find out what these are with respect to y. So what is x in terms of y? Because we'll square both sides, x is equal to 3y. We'll multiply both sides by 3. So now that I know what my now that I know what they are in terms of x in terms of y, I can think about my radius in relation to the line of revolution. So my outer radius, all of these guys, I can find by taking the distance between that blue function and the line of revolution. So my outer function is 3y minus -1, and the inner radius is y squared minus -1. So the reason why we're adding 1 to them is because the distance between our points in the line of rotation, you're going to have to add 1 to each of those things. So now our endpoints. If we're doing our antiderivative, or definite integral, with respect to y, our endpoints are going to be 0 and 3. So this distance here is 3. So to set up our definite integral, the volume is equal to pi from 0 to 3. Our outer function, that's a 3, quantity squared, minus our radius of our inner function, quantity squared, with respect to y. Now, this was a calculator question, so we can set this up on our calculators. Now, we don't have a y button, but we can just tell the calculator to do the definite integral, and we can use x as our variable, so long as we have our integral set up in terms of y. When we do this out, we should get 130.062. All right, lastly for C, I'm going to do C over here. So I'm going to redraw my region. And what we have are squares. Our squares are perpendicular to the y-axis, however, so our squares are going to go back like this. So these are where our squares are going to be. We said before that x was equal to y squared and x is equal to 3y. So to find the length of the squares that we see, if each square has this point on the red function and this point on the blue function, then the side length of this square is going to be 3y minus y squared. Our volume will be equal to the definite integral. We're doing this with respect to y, so from 0 to 3. Each side length of our square is 3y minus y squared, and the area of a square is that side length squared. So this would also be 3y minus y squared, and we're multiplying those two things together. We're taking this with respect to y, Using our calculator to calculate this definite integral, we get 8.1. All right, so those are the two questions from there. On Monday, we're going to start off doing an example like one of these two and see how you guys can do.